Picture this, it's July 2025, and something just shows up in our cosmic neighborhood. It didn't call ahead, it didn't knock, and it was moving way faster than anything that belongs in our solar system. This is the story of a mysterious object that ignited one of the fiercest debates in modern astronomy, a real clash between two totally different explanations for what it could be. Okay, so a telescope down in Chile is doing its thing, just scanning the night sky, and it flags this tiny, faint dot of light just streaking across the frame. When astronomers crunched the numbers on its speed and its path, they realized, wait a minute, this isn't one of ours. It was an interstellar tourist just passing through after a long, long journey from a completely different star system. And this tourist, it was ancient. I mean, really old. Based on its journey through the galaxy, scientists figure it's about 7 billion years old. Now, just to put that into perspective for you, our entire solar system, the sun, the Earth, everything, is only about 4.6 billion years old. This thing was floating around in space for billions of years before our planet was even a twinkle in the cosmos. And this is where things get really weird. As all of our best telescopes scrambled to get a good look, the data that came flooding back was strange. So strange, actually, that it forced scientists to ask a question that usually belongs in a sci-fi movie. Were they looking at a natural, albeit very weird comet, or was this something else? So this thing gets a name, right? It's officially called 3I/Atlas. Atlas is for the telescope system that first spotted it, and the 3I is because it was only the third interstellar object that humanity had ever confirmed. And as it turns out, this third visitor was going to be the most baffling one yet. Let's just quickly recap the family history here. Back in 2017, we had Oumuamua. That was the really bizarre cigar-shaped rock that sped up for no reason. We barely got a look before it was gone. Then in 2019, 2I/Borisov showed up, and it looked and acted just like a normal comet. It was just from somewhere else. And then came 3I/Atlas, and it was bigger than the others, way more active, and honestly, a whole lot stranger. And that brings us to the heart of the mystery. As basically every major telescope we have, both on the ground and in space, turned to stare at 3I Atlas, the data started to reveal these two massive anomalies. Things that just didn't make sense based on everything we thought we knew about comets. So the first big clue came from the James Webb Space Telescope. It analyzed the gas cloud, the coma, that was surrounding this object. And scientists were expecting to see a ton of water vapor. That's what comets do. Instead, they got a total shock. A whopping 87% of the gas was carbon dioxide. Water? It was just a tiny 4%. Just for comparison, our comets, the ones from our solar system, they're basically giant, dirty snowballs. They are dominated by water ice. So to find one made almost entirely of carbon dioxide ice, it's so unusual that scientists called it a 4.5 sigma anomaly. In statistics, that basically means there is an incredibly tiny chance, almost zero, that this is just a random fluke. This was a fundamentally different kind of beast. But the weirdness did not stop there. The analysis also detected atoms of nickel in that gas cloud. And you might be thinking, okay, so what? Well, here's the thing. In the universe, nickel and iron are like cosmic twins. They're born together in the fiery hearts of dying stars, and you always find them together. But with 3I/Atlas, there was nickel, but no iron. That kind of chemical separation is almost impossible in nature. In fact, the only place we see that happen is right here on Earth, in very specific industrial processes. These anomalies were just so bizarre that they opened the door for a truly wild claim from a Harvard astrophysicist named Avi Loeb. He put forward the idea that maybe, just maybe, 3I/Atlas wasn't a natural object at all. Maybe, he said, it was a piece of alien technology. Loeb basically put together a case file, a list of things he said were just too suspicious to ignore. He pointed out its path was almost too perfect, doing these close flybys of multiple planets, all on a nice flat plane. He pointed to that weird industrial-like chemistry we just talked about. And, he said, most suspiciously of all, right when it was closest to the sun, it would be completely hidden from our view. He argued these couldn't all be coincidences. And here's the kicker to Loeb's whole theory. That exact moment when 3I/ATS is hidden behind the sun, that is also the absolute perfect time for a spacecraft to perform something called an Oberth maneuver. It's the most fuel-efficient moment possible to fire an engine to change course, or, as Loeb suggested, to maybe drop off a few smaller probes into our solar system without anyone seeing a thing. So you might be wondering, why would a Harvard professor go out on such a limb? Well, Loeb believes that science has just become too cautious, too conservative. And by refusing to even think about these radical possibilities, we might be missing the very thing we're trying to find. This quote right here perfectly sums up his whole philosophy. But, and this is a big but, the vast majority of the scientific community looked at Loeb's ideas and said, hold on a second. They argue that, yeah, Three-Eye Atlas is definitely strange, but every single one of Loeb's suspicious points has a perfectly reasonable natural explanation. And this chart illustrates their point perfectly. Let's take that whole hiding behind the sun theory. Sounds pretty sneaky, right? Well, it turns out it's not that special. As you can see, somewhere between 20 and 35% of all comets just happen to be blocked by the sun during their closest approach. It's not a clever plan, it's just a common coincidence of orbital mechanics. And they didn't stop there. Scientists went through his list, point by point. That flat, ecliptic path? Well, that's probably just because that's the part of the sky we're looking at most closely. The planetary flybys? Our solar system is a busy place. It's actually pretty likely an object passing through would get close to a few planets. And that weird chemistry? Well, of course it's weird. It came from a whole other star system that likely has its own unique chemistry. And that, right there, is probably the single most important counterargument. Our entire definition of what makes a normal comet is based on a sample size of one, our own solar system. An object born somewhere else, around a different kind of star with a different history, it should look strange to us. Honestly, it would be way more surprising if it looked just like one of ours. So, in the end, the whole debate over Three-Eye/Atlas became about way more than just one weird space rock. It turned into this huge, public debate about the process of science itself, pitting two very different philosophies against each other. On one side of that debate, you have this foundational principle of science. You've probably heard it before. Carl Sagan made it famous. Extraordinary claims require extraordinary evidence. Basically, if you're going to say you found an alien spaceship, you need more than just a few weird coincidences. You need stone-cold, airtight proof. And for most scientists, Loeb's evidence just wasn't anywhere near that level. And that's why all this pushback wasn't about trying to silence him. It was literally the scientific method doing its job. Someone proposed a bold idea. Then, other experts in the field tested that idea against all the available data. And based on that evidence, the overwhelming consensus was that the natural explanation was simply a much, much better fit. So as Three-Eye/Atlas continues on its journey, heading back out into the void, never to be seen by us again, what's its legacy? What did we actually get out of this incredible and kind of weird encounter? Look, in the end, whether it was a comet or a spaceship, that doesn't change the most important fact. Three-Eye/Atlas was a physical piece of another solar system that we got to study up close. This 7-billion-year-old relic gave us a priceless, real-life sample of the building blocks from another corner of our galaxy. It's a time capsule that has already taught us so much. And that leaves us with one last big question to chew on. This whole debate forced the entire scientific community to really think hard about what actual evidence for alien technology would even look like. Three-Eye/Atlas probably wasn't it, but you can think of it as a kind of dress rehearsal. It sharpened our tools and it sharpened our thinking for the day when a visitor or a signal arrives that we really, truly cannot explain away. And it really makes you wonder, what will that day look like?